Hello everyone, welcome to In 5 Minutes. In this video, we are going to see the next problem on type 6. So this is our question. So by looking at this question, we come to know that this is not of type 1, type 2, type 3, type 4, type 5. So this term is not matching with any of the types. So this has to be of type 6. So this is of the type 6 and now we are going to substitute d equal to d by x. So d square will be d square upon dx square. Then we substitute these two terms in this equation. We get d square into y plus 3d into y plus 2y equal to e raised to x. I can take this y common from these three terms. We will get d square plus 3d plus 2 into y equal to e raised to x. The solution for this equation is given by y equal to yc plus yp. First, we will find what is yc. To find yc, we need an auxiliary equation which is given by d square plus 3d plus 2 equal to 0. Again, we have seen this equation. So we are going to just split the middle term as this. After this, we take d common, we get d plus 1 plus we take 2 common, again we get d plus 1 equal to 0. Then we take d plus 1 common and we are remained with d plus 2 equal to 0. So the roots are d equal to minus 1 which will be m1 and d equal to minus 2 which will be m2. For yc, the final solution will be given by c1 e raised to m1x, m1 is minus 1 so e raised to minus x plus c2 e raised to m2x, m2 is minus 2 so e raised to minus 2x. So this is our yc. Now we will find yp. The general formula for yp is 1 upon fd into x. Fd is we have simplified as d plus 1 into d plus 2 into e raised to x. So in previous problem, we have splitted this term in something like this fashion. So we have multiplication in the denominator, we have splitted in some addition terms like this. And we have solved our problem, but now we are not going to split this term. There is another method in which we can solve. So now in this case, we are going to solve problem something like this. Like I am taking this d plus 2 outside and I am considering only this term, which is 1 upon d plus 1 into e raised to x. So if you observe this term is of the type 6, which is equivalent to 1 upon d plus m into v, where v is some function of x. Then its solution is given by e raised to minus mx, y minus m because here it is plus, integration of e raised to opposite of this into v dx. So we are going to apply this formula for this term and 1 upon d plus 2 will remain as it is. So when we apply this formula, if we compare this to, our m is plus 1 and v is this part which is e raised to x. So this part is e raised to minus mx. So e raised to minus x, integration of opposite of this is e raised to x into v. In our case, v is e raised to x into dx. Now we are going to integrate this part. So integration of e raised to x into e raised to x dx, it is equivalent to integration of e raised to f of x into f dash of x into dx. So as you can see here, f of x is nothing but e raised to x. So this term is nothing but equivalent to e raised to f of x multiply by f dash of x. What is derivative of e raised to x? It is nothing but e raised to x. So this term is equivalent to f dash of x. So now we are going to use this property, that is integration of e raised to f of x into f dash of x. Its integration is nothing but e raised to f of x. So in our case, f of x is e raised to x, so it will be e raised to x. So this integration is nothing but e raised to x. So we are remained with 1 upon d plus 2 into e raised to minus x into e raised to x. So now again consider this part. So yp will be 1 upon d plus 2. We have e raised to minus x, then e raised to x. If you observe this part now, this equation is also of the form 1 upon d plus m into v, where v is some function of x. In this case, m is 2 and v is this whole term. So again we are going to apply the same formula, that is e raised to minus of mx. In our case, m is 2, so minus 2x Integration of opposite of this is e raised to 2x into v. V is e raised to minus x, e raised to x into dx. This e raised to minus 2x will remain as it is. This e raised to 2x and e raised to minus x will become e raised to x into e raised to x dx. And just now we solve the integration of this term, which is equivalent to e raised to f of x into f dash of x dx. This integration is given by e raised to f of x. So similarly, e raised to minus 2x, and this integration will be e raised to x. So this is our yp. In this way also we can solve the yp. Instead of splitting into some addition terms, we can keep this term as it is instead of this, and we can solve this term. So this is yp, and final solution will be given by yc plus yp. So our yc is c1 e raised to minus 2x plus c2 e raised to minus x plus e raised to minus 2x into e raised to x. So this is the solution of this problem, and more such problems we will see in our next video. So stay tuned for our future lectures.